Hello, good morning, afternoon, evening, depending on where in the world you are. Welcome to this GSA webinar on modelling tips and tricks. The presentation is mostly going to be by myself, Peter Debney, but we've also got Thomas Lee, one of our developers online, and he's going to be helping me out at the end if you ask any difficult questions and that sort of thing. So, modelling tips and tricks. First one, very often forgotten. Try and keep it simple. Classic mistake is people start off trying doing incredibly complicated models, and it all goes horribly wrong because they've got too much to detail. Basically, if you're modelling an overall structure, keep it simple. If you want to model something to get detailed results, then do a small detailed model. It's obvious when you think about it, but it's often forgotten. So, general principles and note the elements. So, axes. I think everyone is familiar with the Cartesian coordinate system, but GSA also has cylindrical and spherical coordinates which you can use. Now let's go in and have a look at those sort of things. Let me just start up a model. Now we have a grid layout. Now this grid layout at the moment for me is just set up with just 1 meter centers. We can change these. Let's say one is, let's say, half a meter center, and you can see it's adjusted that way. But also, as I mentioned, you can go for. Did I get it right? Wait a minute. Cylindrical grid. Wait a minute. Why is that? Curious. For some reason, I'm not getting. That's the one. There we go. Cylindrical grid layout. I'm just hitting the wrong button. Which you can define yourself and snap to. Now, these grid points. Let me set these a bit further apart. Let me say 30-degree centers. You can use these for drawing in nodes. Let's just draw in some nodes using the Add Nodes tool. And so on. Now, other ways of putting the information in. Now, this is going in currently in the global cylindrical grid. Let me change this back to the global grid. Now, we can also add nodes directly by typing them into these tables, and we can also define elements again directly from the tables by just typing in the values. Now where did that go to? There we go. Element going from node 1 to node 2. Now these tables can be useful, or the graphical methods can be better depending on what you're doing at the time. Now let me just clear this out. You're making cunning use of keyboard shortcuts, and just start off with a simple little two-node element, and we can use the copy commands, and we can copy those, let's say over a meter over in the Y direction. Oh. Or alternatively we can copy the element itself. And because there's nodes there already, it's picked those up. If there weren't nodes there, then it would create them. Now, before I go on, let me just add in an element across the gap here, because we have a useful command which is like copy, but it's called extrude. Not a lot of people are aware of this one. If I select those two nodes there and use the extrude selection, and I send them in the the X direction, couple of copies, 1 meter centers, it just creates copies, but I can include beam elements along those extrusions, and you see, copied those over and joined them up with beams. Or alternatively, I can join them up with quad elements, or both, that matter. But now that's copying extruding the nodes, but alternatively, if I extrude that beam and repeat that command, again, same settings, 2 increments, 1 meter, straight copy, but if I include beam elements, it joins them all up as we go along. Extrude can be very useful, I find. Now, you can of course also do basic geometry creation by importing it from an AutoCAD or a Revit model or so on. Sometimes the geometry can be easier to create offline, as it were. Now, looking at the display of these elements, a number of choices. One, I can select elements and just say show me the current selection. Or there is the volume command, which is one here. If I just go left to right window around those elements, you see it just shows those. Or if I go right to left around those elements, you notice it also picks up those. So it's the same sort of rules AutoCAD, crossing windows and inclusion windows. Now, it's quite easy to find elements and nodes on a model of this size, but imagine you've got thousands of elements. You can use this find command, which is the binoculars, to say let's find node element number 6, and there it is selected. Or alternatively, find node 6, or a range thereof. Or you can also use this to find a range of elements of properties, and so on. Can be quite useful. So, right, let me just bring up a new model and draw in the grid. Now, I mentioned about this snap grid. Now, one thing I didn't mention is if you see, it's wanting to snap just to those intersections, which is fine. But if I turn this snap to grid points off, you'll find it wants to go anywhere, and there's no real control over where they go. Now, this can be a problem. So what we can do, well, there's a number of ways of dealing with this. One of which is drag nodes. Now, if I make sure the snap is back on, I can drag this node and drop it onto an intersection. Alternatively, we can then select all those other nodes. Let me switch the grid off for the moment. And you see we've got a sort of random array. If we want to even these up, there's a wonderful thing called the flex command. Now, if we just straighten up linear, straight line, space them evenly, it just straightens them all up. Alternatively, space proportionally, which might be a useful exercise. depending on the structure. Alternatively, if I was to click on, let's say, that node there, you notice that there is a node in question that the flex command is working on, and then say make those nodes circular. It joins the points up. Or of course, if you want to set a particular radius, let's say of 10 meters, then again you have to. This also works for elliptical and parabolic profiles. Can be a very useful trick, this one. Flex command is quite wonderful. And in fact, I'll just show you. If I go back to this model here, which is going to become, oh, nope, I need nodes, going to become a staircase, well, ramp. If I right click on that end node and flex that node, I'll do a linear flex, move it up 1 meter, lo and behold, the ramp forms. I'll do the same on that end. Oh. And voila, we have a slope. Now, the actual nodal properties, I mean, we can select these two down here. There are options about right-clicking and modifying nodes. Pin them. Or, of course, we can use the modify selection, which is context sensitive. It brings up nodes and element selection and so on. You can also double-click on a node and actually say and edit its properties and its coordinates and so on directly. This also works for elements as well. You know, I double click on that element even though I'm in a node selection, and you can bring up the section properties. People sometimes ask about axes. Now this is a sloping member. If I select those 3 axes, I can create an axis directly by typing into this table. Note the use of the size columns to fit. Very useful command. Alternatively, I can use the create user axis command, and what this then does is we can just toggle through the various options of those 3 nodes until I get to the axis set that I like. I'm going to call that axis is slope. And let's switch that on so we can see. So there. So we have an axis which obviously going up the slope, and and there's the settings, which of course we can then adjust. Yes. Now, one thing I remember about dragging nodes. You see, we've got the node numbers here. This element here is going from node 1 to node 2. If I was to drag that node onto that node, notice it's collapsed those 2 nodes together. Let me just undo that and instead snap it to something very close. There's an option to collapse quints nodes automatically, which we can then do by using this sculpt command, and I'll set that large, and you see it's now cast together. As you notice, there's not quite sure which of the 2 nodes is going to collapse, so you might need to adjust that property, but let's set those back to where we were so we can carry on from there. The supports which we have in here, someone's asked about sloping supports. And if I call up the properties for this node, you notice the constraints as in actually has an axis set up, and so we can do constraints about a slope and say it's going to be the z direction, and so this z direction is going to be in terms of that axis set, not in terms of the global axis set. Can be good. Alright, so that's so that's what 1D elements. Now on 1D elements, beams, and so on. They also have a local. They have a local axis set. X from the first node, second node. Z is as vertical as it can make it, which means the web's always vertical, and Y is the perpendicular left over. If the element is vertical, there is no perpendicular vector with a vertical component, and therefore the rules change, and the local Y is then parallel to the global Y. They have, you can apply an orientation angle to these elements. For example, if we put a 90-degree angle on all these elements, they rotate. Or we could do things called orientation node, or a combination of the two of those. So let's have a look at that. Now if I define some sections, so we can see some small beam, and you can see this beam in the middle is really wants to be in plane with the slab ramp. I can modify that element and give it an angle, but I have to know what the angle of the slope is. Alternatively, I can give it an orientation node and say orientate this beam to node 2, and lo and behold, it's automatically rotated to suit. Always good on circular grids, slopes, and so on. Now we have a couple of modifying commands in here, which is modifying nodes and modifying elements. If I just create a second section, this time I'm going to make it into a channel. What these modify commands do is they take the the element defaults. If I call them my defaults, let's say my default beam is going to be section 2, which is going to be the channel, and I use this modify elements, and I'm going to pick those sections there, and you see these now become channels. Likewise, if I set my node defaults and go for my node sections, I can apply those settings to particular nodes. Right. Okay. Actually, let me just set those two back, or I'll confuse things. Now I'm just going to copy those nodes over. And we have a command down here which is add string of 1D elements. Now this only works if you've got a number of nodes selected. So I'll just pick that, and that will add in the default section. Now we can't select all those nodes at once, because if we do, let me just undo those. Imagine we selected all those. It does what it's asked to do, which is join everything up, which is not particularly useful. So let me just join it. Actually, let's go plan view. Right. Now, when we go to one of the elements, we have options to split these elements. So if I pick that beam there, for example, we can split this into a number of equal parts, or at a distance from one end, or at a percentage, or even at existing node locations. But if I just go for that for the moment, we can also might find that we've oversplit elements. If I select all of those, there is a command recently added into GSA, which is join string of 1D elements. And what this will do is wherever it can, it will join them up. Notice it joined those two up, but didn't join the others. If there are loadings on those elements, it will turn them into patch loads and so on. If there's a change of properties, it won't join them. If it's a large change of angle, it won't join them. But wherever it can, it will join them up. We also have a command called connect, which, if I just draw some, so let's say some cross bracing, select those two, connect one of the elements, and you see what this does is wherever they cross, it puts node in and breaks them. Now, if we were to adding elements by the sculpt, we can obviously snap onto nodal points. We can snap onto midpoints. We can, if we right click and change that snap, go to perpendicular points. Actually, that's quite close to midpoint anyway. And we can also, if I change to align with grid axis, let's say pick on that one, you see it sets it orthogonal with the grid. That's how it all lines up. And yes, it's automatically either broken these elements up, or in this particular case, or it can also actually, if I snap to that one, it's actually extended the elements. I wanted to go over there, but never mind. Right. Now we also have element releases and offsets. Actually, let me just delete out all that. Let's say we want to offset these. Now, offsets are used if you're up against something large, like a column or a concrete wall, or alternatively, you can offset things down to generate composite action. If I offset this element down, let's say minus 100 mil. You see, it's offset down. It's best not to offset everything. I mean, if you just do a simple steel frame, we wouldn't recommend offsetting all the beams down, because it can increase the floor stiffness if you're not careful. Releases, I think most people are familiar with moment releases, but the releases have been updated in 8.5. Let's add in, let's say, major and minor axis bending on that beam, but I'll also actually add in an axial translational release at one end as well, so you can see the green double line there. Now I have got my preferences slightly set because we've got restraint symbols switched on. If we switch restraint symbols off, you'll see these sort of curious labels, fix released, but you also see the more usual pins or Encaster supports down the bottom. So, personally speaking, I prefer the symbols, but it's a matter of choice. Right. Oops. So 2D elements. The axis on 2D elements is a little bit more involved than 1D for obvious reasons. There's more points to worry about. The element z-axis, local z, is defined by the two cross vectors, and then the local x and y axes of the 2D elements are defined by how you define the element itself. If they're set up by local axes, then the local x-axis is parallel to the first side defined. Can be alright for quads, can be a problem for triangles. You can set these to orientate themselves to a different axis set, maybe the global axes, which of course is always supplied. But if you've got walls and so on, then the global axes aren't going to work because they're then parallel to the z-axis, and it's worthwhile defining your own wall axis sets to make sure your elements are correctly aligned. In terms of moment output and that sort of thing, it won't make too much difference, but when you come on to reinforced concrete design with GSA, this will make a huge difference because the reinforcement is orientated by the local x and y axes. So let's have a look at 2D elements. Let's create a new model, and I am going to add in a quad first of all. So I draw, let me switch my snap points on. So there's a quad element, and I can also add in, if I change this to a triangle, so this are overall elements been added. Now these are going to be too large for the moment. Actually, what I'll do as well, I will add in another node in the middle, which will be useful, because what I'm going to do is I'm just going to modify those and just pin those for the moment. Now, elements. If we select all these elements under the Scott menu, we can split them down into smaller pieces. So quad, for example, give me an error because I'm trying to split a triangle as well, but that's okay. Might be 2 by 2, 3 by 2. Oh, let's make it 4 by 4. That'd be alright. That node's not joining up, but never mind. I shall come back to that one. And likewise, I can split that triangle down as well. We have a separate split triangle command, which might be, well, let's say 4, as we said, or alternatively you can split into quad elements, and this sort of warp here can be controlled by this this value, which can produce some dodgy elements because these are not triangles. So at the top they're actually quads, and they will throw up quite an error if you try to analyze those. So let's keep them as triangles. Now, in the case, we could analyze this, but this node is not really attached and it's not quite matching in. I mean, we could drag the node onto there, and so on. That's not very, very satisfactory. So this is where auto meshing will come in, which I'll come back to in a moment. For those of you who've done 2D element analysis, you'll know that where you have support points, you get some very high stress concentrations. And what you need to do is reduce the size of the element local to that point. So if I put it here, big elements are okay in the middle, small elements you need around the edge. And so we have a refine quad element command, which refines at a corner. That goes to corner 1, 2, 3, and 4. So if I do corner 1, for example, it's trying to refine that corner. It wants to be corner 3, and that gives us sort of finer mesh to deal with the change of stress contours and get more accurate results. There's also a command, if I just pick that node there, do the same thing but at a nodal location. So refine mesh at nodes, so it just knows which node. So let's pick these other support points. It works on triangles as well as quads. And you see there's the refinements is done on the triangular elements, and you can repeat this command for as many times as you feel necessary. I mentioned about axes. Now these are currently all set to local axes, and you can spin these elements round. Where has it gone to? 2D elements. And what this does, you see, it renumbers the topology of the elements, and so until this ends at edge 1. But that'll work for some elements, but it won't work for, let's say, the triangles, because we'll never get that triangle to orientate sensibly. What we actually need to do instead, as I mentioned, is to define our property by a global axis, and then they all line up neatly. Now these are all currently quad 4s and triangle 3s, what we call linear elements. But what we using the new MITC linear elements, these can be okay now. They didn't used to be. Used to get a lot of hourglassing problems, but you can change all these elements. If I select all these, we can modify them over to parabolic, which adds in mid-side nodes and additional Gauss points and so on. And there's also a sculpt command to directly do that down there. Now, as I mentioned, this is not a particularly neat mesh. What I'm going to do is I'm going to delete out all these 2D elements. I'm going to delete out all those nodes. I should have undone the parabolic part first, and I want to have all this other missed. Come on. Right. If these are our support points, we can actually create an automatic mesh as well, which can be better. Now we have a thing called the design layer in GSA, which you can just switch as well by right clicking, or of course remembering Control Alt D. And when we're on design layer, the background goes a bit pink. I think rose is the actual colour. And we now have some lines and area buttons. Now an auto mesh is defined by nodes for the corners, lines to give the edges. If I hold the control down, I can carry on and go all the way around. And once you've got a closed loop, GSA in this case will recognise you've got a closed loop and say, do you want to add an area? Now this area defines the 2D property that's going to be created, which might be a void, And likewise the line properties defines either number of segments or step size and so on. I often find the step size gives a slightly better mesh, and you can now got a table view to actually set these up. So if I just set my defaults and just correct those, this is coming in blank at the moment. It's not really blank, it's just the graphics that haven't updated, so there's nothing to worry about there. Now if I select this node there and select that area and right click and add a region, yes, it picks up that area, picks up that node. We don't need the other nodes, there's other lines there, all included automatically. Let's not edit the mode, I shall come back to that, and we can now generate that mesh. Let me switch those nodes off so we can see a bit better. So there is initial mesh. It's not too bad. Maybe let's look at the angle checks. $50, not too bad. How about if we go to the region, edit that and set it to a linear mesh, and then regenerate. In this particular case, hasn't made too much difference. A little bit improvement. And there are also other various settings in the region for quad 4, quad 8. Density, sometimes putting the sparse in can reduce density in the middle, but actually in this particular case I don't think that's particularly useful. Yeah, that's not so bad. Let's go with that. Now this node here is tied directly into the mesh because it's sharing a node, and it's a support point, so in that respect it does need to be. But if this point was instead let's say a node load, so add a node load in there. Switch those contours off so we can see a bit better. Let's see. So we've got a node load on that point, and that's fine. But having these points in can force the mesh to go quite strange if we're not careful. So what we can do instead is, if I select that node and edit it, edit that node, there's a new setting in 8.5 to say mesh attributes and tie this node to the mesh. Instead, if I just switch on my tied interfaces, we'll see if I regenerate this mesh, you see what's happened now is that the node, I should go for plan view. The node isn't directly part of the mesh. It's merely what's happened is that there's now a tied interface, which means these elements here are all constrained. That this node load will actually load up those elements equally, but the tied interface doesn't add stiffness. So rather than a rigid link, it's quite an intelligent way of dealing with these things. Now, so this could be a node load. If you wanted to make that in the column support instead, what I can do with it selected, I can just extrude that down. Actually, let me just change those settings so that is going to be 3, and that bottom one is going to be, well, that's a concrete frame. Let's make it fully fixed. Which if you've got a steel frame, you could pinned at the bottom. Straight pin is not going to be enough because the 2D elements have no ZZ stiffness or drilling stiffness, so I will still need a ZZ restraint on that bottom node. Now this will work as a support point, even though that top end of the column is not directly tied into the mesh. Right. So quick whistle rounds. Questions.